Hello everyone, thanks Raouf for the intro. I'm Laurent, I'm a CTO and co-founder at H, and today I'm going to talk to you a little bit about our work, and really our work, literally like what it is. So me, I like to start the day, and I say to myself, I'm going to do one thing very well. So I'm going to do this slide deck, and then I'm going to open my email. I can see I have 289 emails, and I'm kind of a zero inbox person, so it really disturbs me quite a lot. And then I open my pro email, and I have 1,000 emails. And then I'm going to open my calendar, and then I'm going to put like a bunch of stuff. And like I think we're going to do a lot of micro tasks uh, throughout the days, and this is my desktop, what it looks like. I just put everything in it. I think it's simpler. And then eventually I just create a new folder, old, and I put everything in it. And old is already taken, so I have to name it old 4, for example. And then, so there has to be a better way. And this is what we are trying to do at H. We're trying to build something at the intersection of agentic UI automation and also models. So agentic is basically anything that has to do with autonomy, decision making, planning. UI automation is like how do you deal with software, but through the user interface. So it can be RPA or task execution and model. We think model is important because yeah, you can build on big models, generalist models, and I will say more about that. But we think it's massively inefficient, and we can do a lot better with a specialized model. So um, really, what we are building at H, we are building computer user agents. So agents that can control a computer the same way a human would. So through the graphical user interface. So basically, you take a screenshot and some context, you pass that to the agent, and the agent outputs actions, but in the same action space as you would, like mouse clicks, scrolls, keystrokes. And and the thesis for that is that right now, agent is a big word. You have many agentic company. A lot of that is really RAG or tool call, MCP, APIs, and so on. So plugging it, LLM, interfacing the LLM with like strongly type tools. But we think, it's not going to work for the long tails of tasks that I showed at the beginning. Not all software will have APIs, MCPs soon, and I think there are two reasons for that. One is inertia, in like especially in like big enterprise world. Things are slow, and then there are more adversarial reasons for that, like business model. I think there are a lot of legacy software that have incentives so that this doesn't happen because they sell by the license, by the seat. So if with one license you can do more because you have an agent talking to the license, then they kind of lose money. So they have strong incentives to make that transition slower. And since sometimes they have monopolies, it's going to take a while to happen, this transition to agent doing a lot more in the enterprise. There are also more positive reasons, like there's actually a lot of intelligence that has been put into making the API, making the UI. I mean, the UI, it's like an effective way to present the information. And yeah, maybe like you can already use that context that has been built by many developers as the context for your LLM. And also, if you want to assist humans, it's good if you work in the same action space as they do, so that they can show to the agent how they work, what they do, and the agent can show to them uh, and automate. So there is already RPA where you can automate robotic process automation. So you can automate things through UI, through scripts, and so on. But it's very heavy to deploy. It's brittle. So if exactly the workflow changes a little bit, or if there is ambiguity, it's not going to work. So I think those are the reasons why we need and why we are building computer use agent. So concretely, I can show you maybe an example. So example is a task. Here it's like, okay, we want to go to Google Flight. We want to find a one-way business class flight from Buenos Aires to Amsterdam on January 10, and we want the details of the shortest flight. So there are a lot of kind of like weak constraints in this, and let's see, what an agent is doing. So yeah, if you can please maybe enlarge the, yeah, so we can see. So what happens is that you have basically the software. So here it's a web browser where we're going to navigate on Google Flight, and then the agent is going to take actions. So and every time we see the action, so here it's like clicking on the departure. Now it's writing the provenance Buenos Aires, and yeah. So maybe I can speed it up a little bit. Let's put 2x. But yeah, so the agent doesn't really know how the website works, how if you click on something, what's going to happen. It's really adapting in real time. Here, it's and every step we can see. Basically, it outputs three things: some notes of what happened, what it thinks happened on the previous steps, some thoughts, so what it wants to do now. So now it wants to select one way, and then the action is click on the drop down for round trip because it wants to set one way. Okay, so yeah, and now we are coming to the departure. So departure is really hard because you have to navigate through a calendar. Every calendar on every website is different. And here we want January, so we need to click several times on the next month until we finally see January, and then we can click on 10. And if you want to script that in RPA, it's like a lot of work to explain the loop and all of that. So now it's selecting the class, web search. So now it's going to search. It's going to see the flights. It's going to expand. So it found the shortest one. It's expanding and yeah. So you can do that with RPA, but it would be a lot of work. And here is just one prompt basically. And yeah. So this is our agent Surfer H. Okay. How do I? Okay. Maybe you can lower the screen, please. And the agent, the way it works, so you have the task. That's the prompt I showed at the beginning. And then you have the memory of the agent. And the memory, there are a few things in it. There's the task, the thoughts, the actions, the notes, and the previous screenshots. All of that goes through a policy model. So it's a VLM, a visual language model. So like it can be GPT-5 or Sonnet or model. And then it outputs actions, and we have a few actions. We have like refresh, go to, we have scroll, wait, and write and click. So the agent can write some text onto some element, or it can click on some element. And then we have a localizer model. So when you use an action that has a element target, there is a second call to a model to output the coordinates of that element, and that's the localizer. And finally, when we produce the final answer, we have another call to a validator model, and which validates if the task has been correctly executed or not. And if it has been, we just return the answer, or we incorporate the feedback into the memory and we continue. And every time the action is executed in the browser. And for that, as I said, we can use any model, but we can also use our own model that we developed that comes in. So those are our Holo models um, that we open sourced. They are really state of the art on this task of localization that is given. I'm going to talk more about this later, but yeah, I think one question is why would you use a specialized model? This is 2025, so everyone is just prompting a big model and put your API key and just ship the product. That's what everyone does nowadays. So why bother and why try to do another model that does something? And the reason is really efficiency. And if you look at efficiency, let's take an example. Let's take chess, for example. And chess, you have GPT-5 or Grok that can play chess very well, like 1,600 ELO. Probably like stronger than like most people in this room, stronger than me. So it's quite remarkable that such a big model can play at this level without having be specialized to do it. But if you compare this to a specialized agent and model, like for example AlphaZero it plays at 3,600 ELO, so 2,000 ELO more. So that means GPT-5 is going to win one game out of every 100,000. And it's also a lot bigger. It's like 1 trillion parameter compared to 20 million parameters. This runs on like maybe a big pod of GB 200, $1 million supercomputer. And that one can basically run on a cheap gaming laptop. So all in all, GPT-5 can play chess, but it's like maybe 5 billion times less efficient than AlphaZero at it, or 100 million times less cost effective. So yeah, you have many orders of magnitude, and it really doesn't make sense, economically to play chess with GPT-5. And so that's what we are trying to do here for computer use agents. We are trying to like basically move the Pareto front of performance of the agent. So this is Web Voyager. So Web Voyager is a benchmark. Basically, the task that I showed at the beginning comes from this benchmark. And so you have like 600 tasks, and we measure success rate. And that is basically the success rate of the agent when you use different models. When you use GPT-4o, when you use GPT-4.1, when you do, 4.1 is here. And this is when you use our model that has been specialized for this. And we have like currently a modest 5x cost effectiveness factor, but we are aiming at something closer to 5 billion, hopefully. This is the task I described about localization. So given a screenshot and an intent, here the intent is click on departure date input. You want the model to predict the coordinates. And that's what we worked a lot on. And for this particular task, we also have measured the performance against the size of models. And here, it's not just like us being better, but it's also, I think what's interesting is that you have this, what I call the specialization frontier, where basically every model below, they are generalist models. So here we have Qwen, we have Sonnet, we have actually maybe GPT much below on this particular task. And then here, these are specialized models. And so all of these models, they have been trained specifically for that. These are UI Venus from Ant Group. They have a big team working just on that. This is UiTAR from ByteDance, also a big team working just on this problem. And this is our latest release from 2 weeks ago, Holo 1.5. So yeah, I think we're going to see a lot of these like Pareto plots where specialized model really shine, and people start to move away from generalists because they find it's not very effective. This is how we trained Holo. We initialized the model with Qwen 2.5 VL, which is probably the state of the art in terms of open source VLM, so visual language models. We need to give it a screenshot, so it needs to be a VLM. We start from that, and then we do a little bit of fine-tuning on a mixture consisting of UI localization examples. So we've scrapped many different softwares and websites to get like screenshot intent coordinates. We have other auxiliary tasks that we think are interesting, like question answering on tables, on UI. And then we have a lot of data that consists in execution of our agent on many synthetic tasks. So we have actually expanded this web Voyager to something like 100,000 synthetic tasks on which we've run the agent, and we collected the successful trajectories, and we are training on the successful trajectories for web, for Android. And so that's the phase one, supervised fine-tuning. And then we do a little bit of GRPO, which is reinforcement learning. And for now, we are training the model to be successful, to optimize like end-to-end for being successful at this task, not really reproducing the training data. And right now we are doing it on UI localization tasks, but we hope to expand to many more tasks in the future. So why open? We could also keep the model to ourselves. And these are, I think, all of the reasons why we want to do open weights models. I think for the customer, it builds trust. They know what's in the agent, and we are a startup, so they don't want to be fully reliant on us. If we give them the model, they know they can run it if we go under. It's a good conversation starter. People know, like maybe they've seen the model or the benchmark, so it's a good conversation starter, and they can try it before they buy it. I think it's good for the brand because like you don't have to trust me, you can download the weights and run the evaluation, so it's verifiable performance. For the tech also as a consumer, so when we build open source open weights, we also start from QuentVL in our case, so and we use existing training pipelines, maybe TRL from Hugging Face, maybe we can use also inference like VLLM, like all of the stack is basically already done. And we don't have to reinvent the wheel, we can just focus on where we add value. And then for the employee, I think it's a good drive as well. They get visibility along the way. It can be a long web for a startup to be successful, but this gives them intermediate milestone and visibility, and it helps with retention and attractivity. So I think all in all, it's a good deal for everyone. What is next for us? In terms of research, we want to extend to, we've done the web, we want to extend to desktop and mobile. We want to generalize, so before we trained on Web Voyager, we evaluated on Web Voyager, and because it's reinforcement learning, it's kind of okay to train on the test set, but really it's not, so now we are moving away from that, and we are training on this big only on this big synthetic task mixture that I described. We want to annotate, use like more humans in the loop. Sometimes the agent is really stuck and you need to just show it what to do. So we are building tools for that. And then reinforcement, so do more reinforcement learning to optimize end-to-end for the task execution success. So multi-turn and so on. And then in terms of platform, we are the stuff I showed at the beginning, the demo, we're gonna make it public soon. So that's the Surfer showcase. We're gonna have a portal where you can go and create an account. You have your API key. You can launch the agent. You can do inference of the model. So that's coming very soon. And so with this, I thank you for your attention. I'll leave you with this quote, which is why we think it's important to assist more some kind of low-level tasks. And thank you.